Okay, then let's go ahead. What is the tropical projective torus? R n plus 1 R1. That is the name of the tropical projective torus. As you see, there are many concepts of the torus in the as we have learned. It is the in the general case of the torus we can obtain torus by surface of revolution. That's the circle S1 is rotated by axis. We can obtain torus, or in the algebraic topological sense, we can identify its edges. We can obtain torus. Okay. Or if our plane R is given, R times R is given by identifying integer, we can obtain torus. That is flat torus. Unlike the flat torus, unlike the torus by obtaining surface of revolution, that is always zero curvature, Gaussian curvature every point, because this is just plane. But this guys has different sign of the Gaussian curvature between the position. Or where there is an algebraic torus, the properties of torus is one genus. So if we consider a complex plane C2, and if we get rid of one point, that is because there's one genus that is also a sort of torus. We call that torus is algebraic torus. As you see, this property, when you observe this property, if we goes to left, up, down, left, right, and up, down, that we our position is come back to the inside the scale. So if we see this game, the Japan Sega Masters in the 1855, so-called Teddy Boy, we can see this property. That is left side and right side, and up and down, the same situation, same character is again meet again. Okay. Left side, right and left, because identified, or up and down is identified. You can see the character is lives in the scale space, and that is so-called torus. Okay. Anyway, we can define a concept of new torus. That is concept of tropical projective torus. Definition: tropical projective torus. Let take x coordinate and y. Also, give a relation x, y. In that case, define x1, y1 is equal to x2 y2 xn plus y minus n. So every difference coordinate is equal, same value. Okay. If we understand that situation on the plane in R2, x1, x2, y1, y2, for convenience, I say that point is A, that is B. So if there is x1, x2, that is y1, y2. So the difference, x1 minus y1, in that case, I switch the point, okay, B, A, that is x2, y2, by that, x1, x1, y1, that is x1, y1, x2, y2. So that point distance, that distance is same. Okay. This distance and this distance are same. Then we can regard it, these 2 points as a, in fact that is equivalence relation. Okay. If we check this, you should check this. So because this equivalence relation, we can identify the point A and the point B as the same point. So if we go to this and go to there, that is just you here, you live here. You go, and that is here. Okay? That is like a concept of the torus. So then we can define the equivalence relation is denoted by x. That is because they're same. We can denote it by, in this case, A. Okay. And its set, the set Rn plus 1, its equivalence class is defined by Rn plus 1 R1, and we call that structure a tropical projective torus. Okay, so if we consider this game or the general definition of the torus, that concept is similar to the concept of the torus. Okay, that is different definition of the torus, but we can cast about the name. Why? Okay, we can understand. I understand that is torus. Why the name has projective and tropical? We should check this point. First, the properties of the tropical projective torus, we can identify identify our n, this projective torus with our n. Why? If we consider the relation, that is okay. Just equivalence relation. If we denote this is like this as a representation, in the case xn plus 1, without no confusion, let's define that is just like this. And to check this, the way we're identifying the tropical projective torus with Rn, killing the last coordinate. Precisely, if we take a representation that map, we define the map is like this. x1 minus n plus 1, x2 minus xn plus 1. That part is fixed. So if we go this, the last term is xn minus 1, n plus 1, xn plus 1. So that vanishes. So that map is represented by zero. That plays role in the projective space, dummy variable. Okay, that is also dummy. So we can define just like this. N coordinate instead of n plus 1 coordinate. Okay, then in the projective plane, we can see the last coordinate is dummy, so the dimension is n. So that is also n dimension. Okay, so this, because this has same process of the projective plane, the name projective is reasonable. And the second reason why we can say Rp or Rn plus 1 is related to tropical. There is many reasons. In 2004, that is the result based on the research. The name is the tropical, name of tropical is reasonable. Spire and Strompes identify an equivalent equivalence between the phylogenetic trees space with n leaves. The space is denoted by tau n. I explained what is phylogenetic tree in the section lecture 4 and with the concept of leaves and edge and so on. between the phylogenetic tree and a tropical geometry space via homeomorphism. So the concept of the phylogenetic tree is contained within the Rm plus R1 is phylogenetic tree. As we draw the picture, two branches, a cyclic connected graph to describe the evolution model. Okay, that is a type of projective tropical projective torus. Okay. Furthermore, as this in the lecture 2, I explained that is not a phylogenetic tree because the degree is more than 2, but this image, this branch image, or this image with trivalence, that is also related to tropical projective torus. That is also a type of the tropical projective torus. So, if this name is without this name, okay, that is a torus, but this is related to, including phylogenetic tree, and these guys, a tropical curve is related to these are n plus 1 divided by r1. So the name is contained, because this is contained related to this, the name tropical is quite reasonable. Okay.